Hi, this is Gabriel Gogowski.
I'm Emeka.
I'm Gabriella Bobo.
I'm Chelsea, and our project is on spider gifts. Okay, so for a bit of background, male spiders give gifts of silk-wrapped food to female spiders to convince them to mate with them. And our research question is, does the diet type of spiders affect the weight of their gift made? And is male investment tied to nutritional status? So we're testing to see the significance in the difference in weight and gifts between high food spiders or high food diet and low food and spiders. We took a look at individual gift weights in order to compare two sets of spiders. So some description of our data, we have a male ID for each male spider, and then we have the food treatment. In this case, we use high food and low food diet, the number of trials to make a gift, the prey weight before the trial, gift weight, silk weight, and milligrams, and then we tested the prey weight after, so gift and minus silk weight, and then the prey weight lost. So it shows how much the male spider consumes. And some more description of our data. We have the male mass before the trial. We have the male Ceph width. We have the male R body index, the latency to wrap, the male mass after the trial, and the weight and difference, so before and after, and the taut wrapping duration in seconds. Am I supposed to do this one too?
Yeah.
Okay. Sorry, guys. Um, so as a group, there were no new variables we had to create ourselves, but we did have to focus on the male ID to be able to differentiate further between our data points, the food treatment, so the high food and the low food diet, to know which diet our male spiders adheres with, and then the gift weight to visualize the difference in weight between each male spider.
Okay, so this is the subset of our original data. Here we take a look at the high food diets and the low food diets. Looking at the sample size over here, we can see the sheer number of data that we have for the high food diets versus the much lower number of data that we have for the low food diet. We can also look at the mean, which obviously we can see through that the high food diets have a higher average gift weight. Here we see 22.7 versus the 16.9 for the low food diet. And then the standard deviation, the 16.3 versus the 9 for the low food shows the variability being much higher within the high food diet um, for the spiders. Okay, here we have our box plots. So what does this box plot mean? So the gift weight for the high food diet is higher than the low food diet, as we see by the median. So we see that thick line in the middle. It is a little bit higher than the low food diet. And then the high food diet has more variability, meaning that the high food diet spiders do give heavier gifts, but with far less consistency than the low food diet, which does give the lighter gifts, but at a level of much higher consistency. Here we have our histogram. So what does this show? So similarly to the previous model, it obviously clearly shows the variation between, or the further variation between the high food diets versus the more consistent low food diet. Um, Although it gives a much better visualization in terms of looking at uh, that in reality, the weight for the high food diet spiders, they're still not nearly as high, or they're not crazy different to that of the low food diet. It might be higher, but it is not like a crazy significant number higher. Finally, for this graph, so obviously the high food diet has a wider, flatter curve, showing or representing the higher variance that it has than the low food diet, and the low food diet curve is a little bit tighter and like more peaked, which shows that consistency um, in the weight of their gifts. Um, and so obviously like this graph kind of ties in all the other graphs together along with our data that we picked up, and the fact that the high food diet spiders have more of an investment to give in their gifts, and then there's a lot more variability, but the low food diet has a lot less investment in their gifts and more consistency.
So for statistical methodology, we used population means. So mu1 is the mean gift weight for the high food group, and mu2 is the mean gift weight for the low food group. And we just did it in alphabetical because that's how SAS also does it. And so for our null hypothesis, we have mu1 minus mu2 equals 0, which just means that we think that, or just that the means will be equal, so no significant difference between the means of the weight of the foods for the high food versus the low food diets. And our alternate hypothesis is that mu1 minus mu2 is greater than 0. So this means that we are hypothesizing that the mean weight from the high food group is heavier than the mean weight for the low food group. So we found our point estimate, which would be the difference between the averages as 22 or 5.7663 milligrams, which means that the average high food diets were around 5.77 milligrams higher than the low food diets. And this number is right in the middle of our confidence interval, which we did a 95% confidence interval, which means our alpha is 0.05. And so our confidence interval went from negative 3.6058 to 15.1378. And so what we gathered from our confidence interval is that since one side is negative and one side is positive, 0, which was our null hypothesis, falls in this interval, which means that there's no statistical significant difference between the mean weight of the gift for the high food versus the low food diet. And our test statistic was 1.04, which is a fairly low t-value, also hinting towards no significant differences. And so a p-value is a statistical measure used to determine the likelihood that an observed outcome is the result of chance. And our p-value was 0.1525, so around 15%. And since our p-value is so much higher than our alpha, 0.05, we failed to reject the null hypothesis, which means that there's not enough evidence to support a significant difference in the mean gift weight between the food treatment groups.
So in conclusion, we have to revisit our original research question. Does receiving a high food diet instead of a low food diet increase the weight of the nuptial gift a male spider provides to a female? And whether or not the nutritional status is connected to the male's investment. In response, after thorough statistical research, we found that there is not clear enough evidence or a significant difference in our data due to the information given from our p-value and our confidence interval just shown. The main hindrance of our data and the most difficult part of gathering information based on the data set was the sample size itself. It was extremely small, and especially particularly with the spiders with the low food diet. And starting out with such a small sample and continuing with an average of all of them was difficult to see a real difference between both food groups and their nutritional value. So 3 things we would want to change with this data set and the information we were given with was attempting at getting a larger sample size, which will provide more data, include further spider characteristics to be able to really narrow down where a change is derived from specifically, maybe measuring things such as the effect of the size of the gift and the mating success, so the aftermath. But these are things that would help. And that is it. Thank you so much, and have a good summer.